Hello everyone, I'm Jaron Breen here with your forecast for the southeastern states mainly, but I'll also be talking about portions of the Mid-Atlantic and Central Plains, Mississippi, and Mississippi River Valley, where severe weather is possible this coming week. That is from the afternoon of the 12th through the late hours of the 16th, maybe into the 17th. Welcome everyone to my first live weather video since the free January 21st snowfall and my April 10th briefing at Penn State's John Myers Weather Center. Both, of course, are still available on YouTube. The former, the snowfall, is available on my account, JBreezy101, and the latter is on the Campus Weather Service page. Today, of course, I'll be discussing next week's severe weather, and I'll start with the current weather and then move on to the forecast portion, with emphasis on the uncertainty along the way. Now, if I may be interrupted by the phone, please forgive me. I will probably have to answer the phone. If, of course, there's a family member calling, I have caller ID, so I can just ignore it if necessary. But forgive me if I look over this way to where my phone is. If I do have to answer it, I will pause the video or mute the sound and change the screens before that. Hopefully that does not happen. Also, if you have any questions, I can answer them, but you must submit them through YouTube, through Facebook or Twitter. I cannot answer them using YouTube comments. Although you can easily see them, but I closed that page. So I'm going to attempt to squash, Halloween puns not intended, all the hype that has come out over the past week. But first, I have a few announcements. I'm still waiting on an answer or two from the Environmental Modeling Center on the status of the numerical weather status of the upgrade of the global forecast system. I've been hearing from them once a week on Mondays or early Tuesdays, so I hopefully will hear from them and get some answers early next week. And then shortly thereafter, I will write my NWP update shortly thereafter. At the end of this video, I may discuss briefly the global forecast for the rest of October and how that will affect the winter forecast. That may actually have to occur during the blog, but if I have time at the end, I will discuss that here. And now let's discuss the forecast, starting with the current weather. Here in the United States, there's the stationary front. So here in the United States, there is a stationary front situated along the from the Intermountain West down through the high plateau of New Mexico and over into northern Texas, central Oklahoma, central Arkansas, western portions of Tennessee, into Kentucky, Virginia, West Virginia, and drapes across the southern parts of the Delmarva Peninsula, and then off the coast of New England. The visible satellite shows a huge stratus deck across the country from the Four Corners all the way to the east, as far south as about 100 miles from the Gulf Coast, and from there northeastward back up to the southern Delmarva, where there are mostly clear skies. This is the area that will probably be most affected by the severe weather. Thus, current weather does not much to help us, but it will be quite a dreary one. I will show you the infrared satellite loop. You can see the clouds moving from west to east here, and there's the evidence of the system coming into the Pacific West. It'll likely, and that's the northern branch feature that will affect the severe weather. That will play some of a role in the severe weather next week. Looking globally here in the northern hemisphere, high pressure dominates at least portions of the country, the immediate eastern seaboard and the northern and the Pacific Northwest. There's the low in the Gulf of near the Aleutians, and there's the low that's in the associated fronts that are in the associated front that is bringing all the cloud cover I showed you a moment ago. And another feature that may affect the global weather over the next 10 to 15 days is this system currently located near just north of N. That is Typhoon Vogfon. It is a very, very powerful storm, as you can see by the intense colors on the 500 millibar chart and the extreme low pressure system there. It is a very powerful storm, almost as powerful. It resembles many of the typhoons that have occurred over the past year or two. Haiyan about 2 years ago, and that was Haiyan this past year, and Juggalot the year before that. So that may recur. That is forecast to recurve, and that'll play into the weather pattern beyond next week. But for now, we're focusing on this system south of the Aleutian, just south of the Aleutian Islands. So let's now discuss the forecast portion. See that there's nothing, that we have a trough coming into the west. There's the northern branch, and there's the southern branch on the 500 millibar chart. And as I push this forward, you can see there's the low pressure, there's the low extreme, starting to see extreme values, -1 sigma, which is a standard deviation below normal. That is a strong signal of a trough over the lee of the Rockies. This is Sunday afternoon, so it's just starting to develop on Sunday, the first day of the severe weather. You can see there's still some spread in the ensemble heights. This is the Global Forecast Systems Ensembles, the GEFS, which will be subject to the upgrade, as I alluded to earlier in the video I've been posting about on the JBreezy weather. There's the trough in the east. There's your northern branch. And the northern branch and the southern branch features are starting to align a bit. Still some separation. And I'll show you some solutions. There is a stronger signal now. That went down a little further than I wanted to. You can see there's stronger signal, a -2 sigma anomaly over the Texas and Oklahoma panhandles. That is strong. There is a -3 sigma anomaly, but still starting to see some more spread. But there is at least some certainty in the overall synoptic pattern. And here's where things get crazy. As this thing goes to a negative tilt, that is pushing more from an axis of the trough axis, pushing from northwest to southeast. You can see that there's a lot of spread in the system. Where the 5760 meter line is there, right where my mouse is pointing. That right there is where the still uncertainty in that, but that is clearly showing a negative tilt. Stepping back a bit, back to where the signal starts to come in. This is the CMC signal. And there's still, and that is, no, it's not certain. Yesterday it was not certain. You can still see there's a lot more spread though on overnight Tuesday into Wednesday than there was on the GEFS. So we're going to use the global forecast system now for them to discuss the start discussing the details. And because I have a lot of stuff going here. There's the low that's coming up. That's riding along that stationary front. There's the high pressure system over the Midwest. Here's the surface front. You can see the lee of the Appalachians around the same time on Sunday as the 500 millibar feature. And the surface, of course, is usually more uncertain than the upper levels, but we can tell a lot about where this is placed. The consensus is it's going to be ride the Red River Valley. And here is Monday morning. Looks like you can see that the strongest signal is a little off center with the 1008 millibar isobar. Again, showing you some uncertainty. And that is why that we cannot fully call this an outbreak, because the placement, look at the disconnect between the low pressure center and the anomaly. It's even more defined as well. But we are going to see the low somewhere in the vicinity of, let's say, 38 degrees north throughout the course of the next week. The exact track of this is to be determined. It's coming up from the Texas and Oklahoma panhandles. Again, might see a dry line with that as well. Now let's take a look at, now let's go to the upper levels again. This is the 250 wind, 250 millibar wind. This is the jet stream that we're showing you. We're looking for a strong dip in the jet stream, and we can see that clearly 6Z Monday in the V-wind anomalies. That is strong north-south component of the jet stream. It goes from minus 30 sigma over Colorado, over Wyoming, Colorado, and New Mexico. When it comes back, and you can see the +1 sigma anomaly is a strong south wind component to the wind, at least evidence of a strongish south component of the jet stream up there. Now, so I'm going to close this up here. And before I discuss, look at the jet stream even more in depth. I'm going to check my notifications to see if anyone's interacting with me on Facebook or Twitter. Nothing on Twitter. Nothing on Facebook. Once again, I cannot see you on YouTube if you are commenting. Go to my Facebook, facebook.com/jbreezyweather or twitter.com/jbreezywx, all lowercase. You should get you can comment and ask questions there. I will be looking for them on occasion here. Here is the GFS wind and height, 250 millibars. We'll stick with that altitude. Let's see if, let me see here. I'm trying to get to the, again, I'm using last night's data, which is because a lot of the averages are not as current. Here we go. I can finally get to the hour 66 on the GFS. This is the, now we're using the global forecast system, which is the model that is going to be upgraded pretty soon. What we're looking for is jet streaks right now, and evidence of diffluence in a loft that is going to provide the venting storms need. And we can see evidence of that developing. There's the southern branch feature from South Texas through the Delmarva, through the southern Delmarva, the center. That's the axis. And there's the northern branch. There's the northern branch feature splitting over New Mexico. There's the northern branch going north, northwest, eastward. You can see the strong 70 knot jet aloft. You're seeing that split from the jet stream, and there's the and you can see the diffluence. Half of the wind is going. Most of the wind is going south, and some of it's going north. It should start to become clearer in their runs. Now, Sunday is not the best start of severe weather. There is going to be some. Obviously, in the Texas, Oklahoma, the southern the extreme southern plains and western portions of the lower Mississippi River Valley, basically from a line from 100 miles south of Peoria, Illinois, over to maybe Kansas City, down south, back southwest towards Texas, towards the Texas and Oklahoma, towards the Texas panhandles near Abilene, Lubbock, places like that. That's the area that we're looking for on Sunday. Now here's the wind aloft. As we'll keep cycling through. Now you can see there is evidence of diffluence aloft, of some more more splitting. There's the southern branch going east-south, going from almost due southwest to due northeast, and there's the northern branch coming in. We're still looking. This is valid Monday morning. Oops, I didn't want to click that. They're still looking for strong diffluence, and that's going to be evidenced. Let's go lower. Let's go to the 300 millibars. That might show us the diffluence more. So there's so even Monday there's still some right over the Mississippi River, But at least there's some. There we go. Here's the jet stream now. You can see at the upper levels, there's the negative tilt. International Falls to New Orleans, Louisiana, to east of New Orleans. Negative tilt there. And there's your jet streak. 100 knots, 120 knots, right over central Mississippi, right near Jackson. And you're looking at the upper left and lower right quadrants for the most for the best evidence of divergence aloft. And there you get, and there you can see it there. There's also some distance. You can see the 960 decameter height splitting, going to the Delmarva, while the 948 the 948 decameter low is now over that at that same point near New Jersey for the 960 low. That's all the way up into along the St. Lawrence River up in Canada near Montreal. You can see the diffluence aloft there, and that's going to provide the venting for storms. Let's go down now. Let's go to the surface features and show you the low-level jet. You can see it right there. This is the wee hours of Monday morning. Strong south winds. Right now, a +1 sigma component all along the Gulf of Mexico. And on Monday afternoon, there's the +4 3 sigma anomaly over Nashville from Nashville to Knoxville, over East Central Tennessee, and a wide area of +2 sigma to +3 sigma anomalies in the V winds. That is the north-south component of the wind. That is funneling moisture and provide at least some instability. And here's the Cape valid. You can see strong evidence of 400 of at least of enough Cape 200 joules per kilogram as far north as Chicago on Monday early afternoon. And that's 2 p.m. 18Z Monday, 2 p.m. Monday. But as I said, that there's still a lot of spread as well. Let's go to the European model, showing you 500 millibar heights. And this is Euroweather.com. Here's the height Saturday evening. Here it is Sunday evening. There it is Monday evening. There it is. There's the strong. There you can see the negative tilt coming in, and there it is Wednesday evening. Notice the difference between the 500 millibar pattern on the European model, a closed low, versus what I showed you on the GEFS 500 millibar pattern. There's the strong anomaly, but it's still, you can see that there's no closed contours here. Another aspect of the uncertainty. Closed low over St. Louis on 0Z Wednesday. And no closed low at that time as well. A very strong a very distinct northern branch and southern branch feature, yes, but it's not cut off on the GAFS compared to the European operational. So that leaves a lot to be desired in terms of the details. And once again, there's the spread at 500, even at 500 millibars as well. And if there's enough spread at 500 millibars, you can guarantee the surface features are to be placed with the placement of the surface features according to the model. That should be placed with a grain of salt. I'll go off screen share for that portion. So far we've covered that the 500 millibar pattern is very different on the European operational compared to the GEF, compared to the Global Forecast System ensembles, and that's not even agreeing with, and this doesn't even agree with the Canadian models as well. We talked about the surface that there's a well, that there's enough moisture coming in to bring enough CAPE into Chicago, as far north as Chicago, 200 joules, 1 to 200 joules per kilogram of CAPE, according to the GEFS, as far north as Chicago. So there's going to be severe storms. The question is where, and that's what we're having a lot of trouble with the models, where the low is placed. If you are south and east of the low, in the warm sector, that allows, that's where you're going to get the most severe weather, as well as possibility of tornadoes. Now, even though that there's still enough uncertainty, I'm going to take a look at the global forecast system. Now, when you're looking at the severe weather potential, go back to screen share here. You're looking at, in the upper levels, you're looking for the right entrance and left exit. Here you're looking for the left entrance and the right exit at the lower levels for evidence of convergence. And you can see that there's convergence of the wind. You can see that the isobars are fairly, the height lines are at 850 millibars. There's the low level jet, 70 knots, by the way, up in Kentucky and in Ohio. This is valid on Tuesday morning. Everything tightens up. There's a south wind here apart from Florida and Georgia, eastern Tennessee, into eastern Kentucky, and there's the southwest wind in western Florida up to that point. There is convergence of there's confluence, I should say, here, and over Mississippi and over Alabama. There is that is also convergence based on jet dynamics, low-level jet dynamics. You're looking at the left entrance region for convergence. There it is. Hi, I'm doing a video. Sorry about the interruption. And there's the low-level jet. Strong low-level jet indicating a lot of moisture coming out from the Gulf in the area of the left entrance region over Mississippi, over Alabama. That is where you'll be looking at the best chance of initialization for the severe weather. Now let's take a look at a sounding. Let's look at Huntsville, Alabama. That's approximately where I am. That's approximately where I'm going to look at. Just to take a look at things, this is the GFS again, not the best model to be looking at soundings with. But we can get an idea as to what's going to happen. You don't see instability here. You don't see a lot of shear as well. Let me head to northern Georgia instead. I might be heading too far east. There you can see some evidence there. There's the south-southeast wind at the surface, becoming a little more westerly aloft. So while tornadoes are not the highest on the priority, you're looking at the possibility of tornadoes in some parts. Again, a lot of uncertainty. This is the GEFS. This is the global forecast system that we're looking at. But look at this photograph. There's at least enough. There's a nice curve. For up there's the 1 kilometer height, and you can see there's enough speed shear here. Guess about 30 knots of it, and that's 6 kilometers. 55 to 60 knots. Definitely showing you potential for severe weather. Definitely showing you enough shear to overcome any instability that might be lacking, at least in northern Georgia. And you can think to be applied to certain areas as well. So once again, the uncertainty preventing us from calling this an outbreak is the difference in the heights on the global on the GEFS, which is the global ensemble forecast system. CMC as well, not a strong signal there. And of course, the European Center, their model is predicting a closed low as opposed to a southern branch feature. And if it is a closed low, that's going to move. We know that moves slower. That moves slower than a pattern like the GEFS showed. I'll bring that back up, zoomed in a little bit here. That moves, the GEFS would move faster than a closed low of the European. And we can't even, and because of this uncertainty, we can't place the surface, the triple point anyway, with much accuracy, even a few days out. There is evidence that there's going to be strong moisture advection with the low-level jet, strong diffluence aloft, and that's going to be enough, and there's going to be enough lift. Talking a few embedded supercells, but mainly looking at a damaging wind threat with isolated spin-ups within the squall line, what we call a QLCS tornado event. And that's the gist of it right now. That pretty much covers all I wanted to cover for now. Once again, I'll be having a blog. Entry on the numerical weather prediction. And I ran out of time. I figured I ran out of time here. I'm not going to go into the winter weather now with the winter forecast. What I'm watching though is Eurasian snow cover through the QBO and now the SAI, which is Dr. Cohen's cup of tea. And I'm also watching, of course, the ENSO, which is El Niño Southern Oscillation, El Niño La Niña. I'm watching how that evolves, mainly how the water, mainly ocean heat content, where the warmest water and the coldest water is, as far as depth is concerned. I'm also, and of course, I'm watching the Atlantic and the Arctic. Most likely, the biggest things I'm looking at is ENSO, Eurasian snow cover, ENSO, El Nino, the North Atlantic Oscillation, and the Pacific North American Oscillation. Those are the big ones, and I discussed that in my video for my Penn State briefing on April 10th. So look for the blog on jbreezywx.blogspot.com on the NW numerical weather prediction update, and I'll be discussing briefly on the global forecast. But Typhoon Vagfon may actually play a role in that as well, bringing moisture and strong heights to the 500 to the upper level, to the jet stream. That's always a bit hot topic in the tropical synoptical world. Thank you to everyone for watching, and before I end this video, I will now attempt to answer any questions that have been submitted. I don't see any on Facebook here. I think I've gotten some on Twitter, so I will go to Twitter here. Nothing on J Breezy Weather. Nothing on JM Green 101. Okay. Thank you for tuning in. Once again, severe weather is likely from the southern plains over to the mid-Atlantic and southeast coast over the coming days. And I will conclude that with the Storm Prediction Center's forecast. They should be your primary source for severe weather. Although local media, local news, AccuWeather will also have a role. And yes, they do have a severe weather area. Here it is, day 4, which is Sunday, it's actually Monday, exactly where I said it would be. The lower Mississippi River Valley into eastern Texas. And that's a 30% risk. In about a week from now, they'll go to their 15 and 30% risk areas. Here is Sunday's forecast from the Prediction Center. There it is, slight risk of severe weather. Texas, Oklahoma, and Arkansas. The 5% extends out to Cairo, Missouri, to Cairo, Illinois, back up near southeastern Colorado, down to Austin, Texas, there, of course, Waco to Tulsa, out to including Oklahoma City, Wichita Falls, out to Little Rock. That's this area of 15% risk, slight risk. Starting, that's a fairly thin area of 5% risk of severe weather. There's too much uncertainty beyond Monday for the 30% risk to extend that to the east, but do look for that in later outlooks. Once again, thank you for tuning in. I'm Jaron Breen. Have a great evening. Have a great day.